Good morning, students. I'm Visweswara, sir. Today, I'm discussing eudiometry. I will discuss two different models in eudiometry. So, in eudiometry, generally, this kind of that means the wording used by paper setter involves these substance, these solutions. So, this is absorbent and gas is absorbed. So what kind of gas is absorbed by particular absorbent? They use, that means this kind of wording they use in the question. If you know these things, you can easily solve the problem. Alkaline solution, sodium hydroxide solution or potassium hydroxide solution or anything. For example, paper setter may also give barium hydroxide solution. Generally, he gives sodium hydroxide, potassium hydroxide, and a simpler write, etc. That is a basic solution. They absorb, those basic solutions absorb halogens, carbon dioxide gas, sulfur dioxide gas, sulfur trioxide gas. Most of the cases we will get the carbon dioxide gas. But as that means information, I'm giving other things also. So how sodium hydroxide absorb carbon dioxide gas? Carbon dioxide is acid, no? Sodium hydroxide is base, no? That is simple acid-base neutralization reaction. You will get sodium carbonate. Sodium hydroxide absorbs halogens. How you will get these reactions in redox titrations and also in the 12th class group number 70. And SO2, SO3, these are also similar to carbon dioxide. SO2 is acidic oxide. Because it is acidic oxide, it is taken by sodium hydroxide in acid-base neutralization. And you will get Na2SO3, sodium sulfide. In the same way, SO3 is etheric oxide absorbed by reacts with sodium hydroxide. You will get Na2SO4, sodium sulfate. That is the way by chemical reactions, these gases are absorbed by the alkaline solution, sodium hydroxide solution or potassium hydroxide solution. So now, to absorb oxygen gas, you need alkaline pyrogalol. Pyrogalol is a substance. So knowing about its structure, it's not at all necessary. Alkaline pyrogalol means it is made alkaline by adding little bit of first group hydroxides. It's anything, sodium hydroxide or potassium hydroxide, you take anything. It absorbs oxygen gas. Turpentine oil absorbs ozone gas, and concentrate H2SO4, P2O5 are used to absorb moisture. Moisture means water vapor. And heated metals like palladium, platinum, they absorb hydrogen gas. That means hydrogen gas enters into the interior of the palladium and platinum heated metals. So this is the information you need to solve these problems. And two type of problems will be given by power sector. But this is important. I'm saying this question that means in every examination. So once you say halogens, CO2, SO2, SO3 absorbed by this one by chemical reaction, O2 is absorbed by pyrogalol solution. For O3, you have to use the turpentine oil. To remove the moisture, you have to use H2SO4 concentrated. Those are dehydrating agents. That means they remove water, and P2O5. And this is very important concept. You will get this one also in the 12th class surface chemistry. Metals take a hydrogen gas. This point already discussed in the hydrogen and compounds. Large quantities of hydrogen can be stored in the palladium. Okay. So palladium is the good storage metal for the hydrogen gas. Right. So once you know this information, now come to the combustion of hydrocarbon, the general equations. That means if you know these equations, how to write, how to balance this one, then you also feel comfort here. For example, any hydrocarbon, any organic compound, in fact, so many organic compounds are there. On burning, they give carbon dioxide and water. So I will take alkane first. Alkanes general formula, that means I am taking general equations. I written general equations, that is the general formula of alkane. To burn this alkane, I need oxygen. That is nothing but O2. Once hydrocarbon completely burns in oxygen, you will get carbon dioxide and H2O. You will get these things. Now you see you have to balance the equation. By having the balanced chemical equation is not good. That's difficult. Okay. You may not remember that one in the examination, right? So you have to by heart the instead of by heart in the equation, you have to balance the equation. Here, how many carbons are there? N carbons are there. So you simply write N here. That means NPO2. And now balance the hydrogens. So first of all, you have to balance the carbons and then hydrogens and last oxygens in combustion reactors. And this is nothing but you say 2N plus 2 hydrogens are there. If I write N plus 1 here, immediately, so N plus 1 multiplied 2, N plus 1 multiplied by 2, 2N plus 2, you will get the number of, that means if I write N plus 1 here, immediately number of hydrogens got balanced. So this one, carbons balanced, hydrogens balanced, depends, you have to balance the oxygens now. To balance the oxygens, here you count how many oxygens are there. N multiplied with 2, that is nothing but 2N oxygen atoms are there. And in this case, and N plus 1 into 1, that is nothing but N plus 1 oxygen atoms are there. So total number of oxygen atoms is nothing but 2N plus N plus 1, that is equal to 3N plus 1. Oxygen atoms are there. So 3N plus 1 oxygen atoms are there. Friends, now you see I have to balance this one. That means right hand side 3N plus 1 oxygen atoms are there. I want to get 3N plus 1 oxygen atoms on the left side. I write like this. So what is the meaning of that? 3N plus 1 by 2 multiplied by this 2. That is nothing but 2 get cancelled. And now you will get 3N plus 1 oxygen atoms on the left side. So what I written here, that is the balanced chemical equation for the combustion of alkanes. In the same way, you can also do for alkanes. Alkanes general formula CnH2n plus oxygen. Any hydrocarbon gives CO2 plus H2O. This is nothing but CO2 plus H2. N carbons are there, N CO2. That means I'm balancing it. 2N hydrogens are there, I simply write N. Once I write N multiplied with 2, that is nothing but 2N. How many oxygens are there on the right side here? 2N and plus N. That means I will count here. And 2N oxygen atoms are there here. And N oxygen atoms are there here. N plus 2N is nothing but 3N oxygen atoms are there on the right side. To balance the 3N oxygen atoms on the left side, I will write 3N by 2. So once I write 3N by 2, you can easily understand this one. 3N by 2 multiplied with this 2. Now you will get the number of oxygens. So 2 get cancelled, that is equal to 3N oxygen atoms you will get. That means left hand side, right hand side, you just balance the oxygen atoms. So you balance everything, left hand side and right hand side. Now I will go for the alkynes. Alkynes. So alkynes is nothing but CnH2n minus 2, that is alkyne. Burning in the presence of oxygen. Again, you will get the same thing, carbon dioxide and water. CO2 plus water. So now you say how many carbons are there here? N carbons are there. Friends, I will write N to balance the number of carbon atoms. I am doing that one continuously. Okay. So this is nothing but N. Now how many hydrogens are there? 2N minus 2. I will write N minus 1 here. Once I write N minus 1 here, N minus 1 multiplied by 2, you will get 2N minus 2. That means to balance the hydrogens, I am writing N minus 1. N minus 1 multiplied with 2, 2N minus 2. Hydrogens got balanced. Now, once you balance the hydrogens, now come to the oxygens. How many oxygens are there this side? 2N oxygen atoms are there this side. How many oxygen atoms are this side? N minus 1. And this is nothing but 2N plus N minus 1. And this is nothing but 3n minus 1 oxygen atoms are there on right side. So to balance that many oxygen atoms on the left side, you write 3n minus 1 by 2 O2. So that means 3n minus 1 by 2 multiplied with this 2. That means that is nothing but 2. And how many oxygen atoms will get now? That is nothing but 3n minus 1 oxygen atoms will get. You see, this is how you have to balance the general chemical equation. If chemical equations are given, acetylene is there, you can balance. That means, for example, acetylene is given by paper sector. That numbers you can easily balance. You know how to balance the equations. So 2 here, and that means to balance the 2 carbons, you write 2 here. To balance the 2 hydrogens, already 2 hydrogens are there. Now 2 into 2, 4 plus 1, 5 oxygen atoms are there, right hand side. To balance that, you simply write 5 by 2 O2. So if anything like with the numbers is given, that is okay, that we can balance that one. But numbers are not given. If you want to write general equation, this is the procedure to write the general equations. Okay. Now you are supposed to write, but that means the paper setter gives in the problem alkane. This is why I am taking alkane. I can write the general equation for alkane. If he mentions alkane, I can do that alkane thing. If he mentions alkyne, I will do alkyne thing. But he sometimes he will not mention anything. He never say. Sometimes he may not say alkane, and alkane specifically. He simply says hydrocarbon. Visweswara, I am taking hydrocarbon. 10 grams of hydrocarbon I am taking. I am burning in the oxygen. What is the formula of hydrocarbon? This is one model. So if he gives hydrocarbon, that means for a hydrocarbon, how to write the combustion reaction? So this is nothing but hydrocarbon. For hydrocarbon, how to write the combustion reaction? Hydrocarbon is not mentioned particularly. Alkane is not mentioned. So I will general write CXHY. I don't know how many carbons are there. I put X. I don't know how many hydrogens are there. I will put Y. And it is combined in the presence of oxygen gives and carbon dioxide plus water. Okay. Now you see, I'm balancing the equation. X carbons on left side, I will write X here. And Y hydrogens on the right left side, I will write Y by 2 here. Why I am writing Y by 2 here? Y by 2 is multiplied with this 2. So 2 get cancelled. That is nothing but Y. And that means this side Y hydrogens are there, this side Y hydrogens are there. That means I balanced the hydrogens. The only thing is I have to balance the oxygens now. So how many oxygen atoms are there here? How many oxygen atoms? Y by 2 oxygen atoms are there this side. So Y by 2 oxygen atoms are there. And this side 2x oxygen atoms are there. 2x oxygen atoms means x into 2. 2x oxygen atoms. So total. That means the total number of oxygen atoms is nothing but 2x plus Y by 2. That is the total number of oxygen atoms. Now this side I have to balance the oxygen atoms. What I have to write, you already know what I'm going to write. 2x plus Y by 2 by 2. So what is the meaning of this? The meaning of this one is nothing but 2x plus Y by 2. 2x plus Y by 2 by 2 multiplied into 2 with this 2. So that you will get that means 2 get cancelled, you will get 2x plus Y by 2 oxygen atoms. So this side and this side same oxygen atoms. But so you can also simplify this one. Okay, I balanced everything. I got this balance now. You can also simplify that one. That means instead of writing 2x plus Y by 2 by 2, I'm simplifying this one. First of all, I will take numerator. In the numerator, LCM is 2, and here 4x and plus y divided by 2. That means I simplified the numerator here. I've taken the LCM here. And here 1 into 2, 2 into 2, that is 2, 4x here plus y. And this is a by b by c can be written as a by b into c here. So I'm doing that one. I'm doing that one, friends. Otherwise, I will do one thing done. So no LCM, nothing. I will do one in a different way. That means easy way. So a plus b by 2 means you can write a by 2 plus b by 2 now. You can write like that. This is also I'm writing 2x by 2 plus y by 2 by 2. So in the same way, here I written, that means I'm dividing this part and I'm dividing this part. So 2x by 2 is nothing but x, that is nothing but x. And this is, you can write y by 2 into 2. That means I told you, a by b by c is equal to a by b into c. So x plus y by 4. So instead of that, you can run. So this is simple calculation now. That means I am maybe insulting you. You already know this calculation, but I'm little orthodox. That's why I'm clearly explaining. Maybe one or two students may feel difficult in calculation part also initially. Initially, coming from 10th class, learning a very high level of subject is not easy. It needs a lot of patience from the student side and from my side also. Okay. So both we have to work together to understand this difficult concept. 10th class, you don't have much chemistry now. Okay. So instead of writing this one, that is nothing but this part, I will write this one x plus y by 4. That is nothing but x plus y by 4 O2 gives, and XCO2 plus y by 2 H2O. I can write this balanced chemical equation whenever I need to write it in solving the problems. Right. So this is the general equations. If alkane is given by paper setter, we write like this. Alkane is given. Alkane is given. That when they give some data, they will ask the what is the formula of hydrocarbon. This is one set of the problem. Okay. Now I'm going for that one, Anna. So that means now I will solve the problems here. I'm having two problems here. Two problems means two different problems. Now these are two different problems. Okay. So you see the first one. That means I will solve this problem so that you will understand what I'm telling here. And this is the first problem I want to solve for eudiometry. In this case, they are giving some data. You are supposed to identify the formula of hydrocarbon. That's what I'm telling. That is one model. Okay. So you say 7.5 ml of gaseous hydrocarbon. Paper sector giving 7.5 ml. So for I'm having 7.5 ml of gaseous hydrocarbon. Hydrocarbon. He is not specially mentioning it is alkane, alkane, alkyne. He simply saying it is hydrocarbon. Was exploded with 36 ml of oxygen. 36 ml of oxygen exploded with 36 ml of oxygen. So hydrocarbon 7.5 ml treated with 36 ml of oxygen. The volume of gases on cooling. On cooling means hydrocarbon burns in the presence of oxygen at high temperature. Water will be the gas. You will get carbon dioxide and water. Na? Any hydrocarbon burns in the presence of oxygen, you will get CO2 and water. Na? CO2 is already gas at room temperature, but water is a gas at high temperature of the chemical reaction. That's why paper set are telling you cool it. Once you cool it, water becomes liquid. That is very important thing. On cooling, the volume of gases on cooling was found to be 28.5 ml. 15 ml of which has out of the 20 total volume of remaining gases 28.5 ml. 15 ml of which out of the 28.5 ml 15 ml was absorbed by KOH. Immediately you come to the table first I discussed. 15 ml absorbed by KOH means out of this 28.5 ml, this 15 ml must be carbon dioxide. Carbon dioxide is absorbed by, on combustion you will get what? No. You are taking hydrocarbon 7.5 ml. Combust burned with 36 ml of oxygen. That means in this case, all the 7.5 ml hydrocarbon burned. in oxygen. After the reaction, maybe oxygen left, 36 ml oxygen you are taking, maybe oxygen left. You are getting carbon dioxide gas also. Water is not gas at room temperature. So you are having two gases. And total gas volume after the reaction 28.5 ml. After the reaction, total gas volume 28.5 ml means out of that 15 ml must be carbon dioxide taken by KOH. So 28.5 minus 15. The remaining. Okay. So the rest was absorbed in solution by alkaline pyrrolidol. The rest, that means 28.5 minus 15, that is nothing but 13.5. Absorbed by alkaline pyrrolidol means that 13.5 ml must be oxygen gas. So you started with 36 ml oxygen. So entire 36 ml oxygen is not used in the reaction. Out of 36 ml, 13.5 ml still left in the reaction. It means that all the 7.5 ml hydrocarbon is completely burned. You are taking excess of oxygen. In excess of oxygen, everything hydrocarbon will burn. Nothing of hydrocarbon left. It means that still oxygen is left after the reaction. Means whatever the hydrocarbon you taken starting, that is completely combust. So the information, so you got how much carbon dioxide formed, how much volume of oxygen left, you can solve the problem. If all volumes are measured under same condition, the formula of hydrocarbon is. So now you say, because it is a hydrocarbon general equation, just now I balanced this one. Just now I explained how to write the combustion of hydrocarbon. This is how I written on. Now, from this balanced chemical equation, this is liquid. So don't worry about the water. Water is liquid, friends. Leave water out of this one. At room temperature. Cooling, you cooled. But here 1 is there, stoichiometric coefficient. Here x plus y by 4 is there. Here x is there. These are the stoichiometric coefficients. Once you got the stoichiometric coefficients, you can write 1 ml. Immediately you point out, sir. Here 1 means you generally write 1 mole, na, sir. 1 mole of hydrocarbon reacts with x plus y by 4 moles of oxygen gas and gives x moles of CO2, y by 2 moles of water. That is what a stoichiometric coefficient means. But you are immediately not writing that one. You are writing in volumes. Why you are doing like that? I am doing like that because at a constant pressure and temperature, constant, Avogadro's law says that volume is directly proportional to number of moles. Volume directly proportional to number of moles means a general chemical reaction is carried at a constant pressure and temperature in the laboratory. So volume directly proportional to number of moles means instead of number of moles, you can take volumes. Instead of writing 1 mole, you can directly write 1 ml. You can solve the problem in volumes. If a pressure and temperature maintained constant. That's what I'm doing. Because paper setter given 7.5 ml of hydrocarbon. Paper setter is not giving the data in moles, he is giving the data in volumes. Directly you solve the problem in volumes. So 1 ml of hydrocarbon reacts with x plus y by 4 ml of oxygen, you will get x ml of CO2. But 7.5 ml of hydrocarbon, this is coming from the equation. 7.5 ml of hydrocarbon given in the problem needs 1 ml hydrocarbon needs x plus y by 4 ml. 7.5 ml needs how much oxygen? 7.5 multiplied by this one. 1 ml of hydrocarbon gives x ml of carbon dioxide. 7.5 ml of hydrocarbon gives how much carbon dioxide? 7.5x of carbon dioxide. But while studying the problem itself, you decided the volume of gases on cooling was found to be 28.5 ml. That means the remaining oxygen and formed carbon dioxide together 28.5 ml after the reaction. 15 ml of which is absorbed by KOH, 15 ml is carbon dioxide. The remaining 28.5, 15 minus 15, 13.5 is absorbed by alkaline pyrrolidol. This must be oxygen. So You already calculated carbon dioxide 15 ml. You already calculated remaining. No, this is not remaining. I'm sorry. So how much carbon dioxide is formed here? 7.5x is formed. You already calculated that one. Copper sector given Visweswara, it is 15 ml. So volume of carbon dioxide formed during the reaction 15 ml. The 7.5x CO2 must be equal to 15. X is equal to 2. X is equal to 15 by 7.5. That is nothing but 2. So I got X carbons. Now I have to decide Y. Now you see after the reaction together volume carbon dioxide formed, oxygen left na 36 ml of oxygen you taken na. Out of the 36 ml of oxygen, how much consumed? None. This is consumed none during the reaction. 1 ml needs X plus Y by 4 ml of oxygen for complete reaction. 7.5 ml needs 7.5 into X plus 4 Y by 4 ml for the oxygen. That means, 7.5 ml hydrocarbon needs this much oxygen. So you started with 36 ml of oxygen. This is consumed. How much is left? 36 minus 7.5 into X plus Y by 4 left none. So this left is equal to 13.5. Paper sector telling 13.5 ml of oxygen is left, absorbed by pyrogalon, alkaline pyrogalon. So volume of oxygen left given by paper sector 13.5. Volume of oxygen consumed in the reaction. So this is the left pens. How much is consumed? Taken 36 ml. So taken 36 ml pens, 36 minus 13.5. That is consumed. 22.5 ml is consumed. So how much oxygen is consumed here? For 7.5 ml, 7.5 multiplied X plus Y by 4. This is consumed. So you also calculated the volume of oxygen consumed 22.5 ml. So this must be equal to this 22.5 ml. You'll get easy calculation, this one. Or you can solve this problem. 36 is taken, 7.5 X plus Y by 4 is consumed, 36 taken, this much consumed. Left is equal to 13.5. You can also use this equation. Look at the same thing. Or you can do like this one. Volume left, volume consumed in the reaction 36.13 minus 36 minus 13.5, 22.5. Same thing. I'm just doing the same thing, but step by step manner. So volume consumed is equal to volume of oxygen consumed. This is the volume of oxygen consumed. 7.5 multiplied X plus Y by 4 is equal to 22.5. The only thing is calculation part now. So I'm going for the calculation part now here, and this is nothing but, okay, right. Why I written here X is equal to 2? I already got X is equal to, that's why I simply written there. Okay. So X in the place of X, because I already got that, I substituted 2 here, 2 here. This is 7.5, I will take this side, that means 22.5 by 7. This is exactly 3 times. So 2 plus Y by 4 is equal to 3. Y by 4, I will take 2 this side, 3 minus 2, that is equal to 1. Y by 4 is equal to 1, Y is equal to 4. You got Y also. X already you got Y. Given hydrocarbon is CXXY, that is C2H4. That is the given hydrocarbon. Okay, so that is the first problem here. In another model, this is one model now. They will ask, they will give data like this, and they will ask you what is the formula of hydrocarbon. Sometimes paper sector directly go alkane, alkane, alkane also, and solve the practice of many problems. You will get this one. The next model is paper sectors will give hydrocarbons to you. That means I'm coming to the next model. It's a little bit more complicated than this one. Okay. And this is nothing but problem number 2. I'm giving like this. Okay. So what is this problem? You see, the problem is nothing but a mixture of methane. Paper sector directly giving Visweswara, I'm having methane. Ethene, C2H4, ethane, acetylene, ethine. So mixture of methane, ethane and acetylene, they are giving, and the vapor density of a mixture is 11.3. They are giving vapor density of mixture is 11.3. And they will do some experiment. I'm coming to that experiment. What they will ask, 10 ml of this mixture I taken with Visweswara, in this 10 ml of mixture, how much methane is there, how much ethane is there, how much acetylene is there. That means they will ask you to find the composition of the mixture. This is another model in the Eudiometry. So two models. You are supposed to find formula of hydrocarbon from the given data. You are supposed to find composition of a mixture from the given data. So what they are doing to find the composition, they taken 10 ml of mixture. 10 ml of mixture is burned in the presence of 30 ml of oxygen or spark together. You are burning them, and yeah, over aqueous KOH, you are passing the coming gases. That means you will get carbon dioxide. All hydrocarbons burns to give CO2 and water. So you are passing the coming gases out. The outcome of the gases over aqueous KOH, it absorbs carbon dioxide gas. The volume contracts to 5.5 ml. Volume contracts to 5.5 ml. And then disappears when pyrogalol is introduced. That means that pyrogalol absorbs oxygen gas. Carbon dioxide absorbed by aqueous KOH. Oxygen is absorbed by pyrogalol. If all the volumes are measured and under identical conditions of temperature and pressure and humidity, that means the paper sector clearly telling temperature, pressure, humidity constant throughout the calculation. That means paper sector clearly telling volume is directly proportional to number of moles, and paper sector suggesting that solve the problems directly in volumes instead of number of moles. Both are same. Calculate the composition of original mixture. So I have to analyze this one. So here I given at a constant temperature and pressure, Avogadro's law, we can solve the problems like this. Now come here, I taken 10 ml of gaseous mixture, it contains methane, I taken X ml, I will consider that X ml is there, I have to find what is X. Ethylene Y ml, remaining, that means total 10 ml on acetylene. What is the volume of acetylene remaining? That means 10 minus X minus Y ml. The remaining is nothing but acetylene. Okay. So this is the, now I will write combustion reactions one by one. This is the methane combustion reaction balanced chemical equation. I am not taking water, and definitely we cool the reaction mixture to room temperature. Water is not a gas there. So I am only confining to the gaseous things. From the equation, I boxed this one on. That means from the equation, here 1 is there, no 1 ml, here 2 is there, no 2 ml. 1 ml of methane burns in the presence of 2 ml, you will get 1 ml of carbon dioxide. But how much methane I taken? X ml of methane I taken. 1 ml needs 2 ml of oxygen for the combustion. X ml needs how much oxygen? 2x ml. 1 ml methane gives 1 ml of carbon dioxide after the reaction. X ml of methane gives how much? X ml. 1 ml is giving 1 ml, X ml gives X ml of carbon dioxide. So this is from methane side. Methane requires 2x ml of oxygen for combustion, and it produces X ml of carbon dioxide. In the same way, come to the ethylene, that means ethane. So this is the balanced chemical equation of ethane. Here 1 is there, here 3 is there, here 2 is there. So 1 ml of ethane needs 3 ml of oxygen for combustion and gives 2 ml of carbon dioxide. Now 1 ml needs 3 ml. But YML of ethane is taken. I considered ethane volume is YML. For the combustion of YML, you need how much? That is nothing but 3 YML you need. 1 ml gives 2 ml, now YML gives 2 YML of carbon dioxide. That means by burning of YML of ethane, I am getting 2 YML of carbon dioxide and I need 3 YML of oxygen for combustion. This is from the ethane. So I will add all the carbon dioxide volumes, all the oxygens consumed in the reaction, and I will get through the problem. No, don't worry. But it is not straightforward now. You have to be careful this one. So now come to the acetylene one. That means this is acetylene. Acetylene balanced chemical equation, burning of acetylene balanced chemical equation. Here 1 is there, here 5 by 2 is there, here 2 is there. That means from the reaction, here 1 is there, 1 ml of acetylene needs 5 by 2 ml of oxygen for combustion, gives 2 ml of carbon dioxide. But how much acetylene I am having at my disposal? I am having 10 minus x minus y ml. 10 minus x minus y ml acetylene needs how many ml of oxygen? That is nothing. 1 ml needs 5 by 2, but this much needs 5 by 2 multiplied this one. 10 minus x minus y into 5 by 2 ml. 1 ml gives 2 ml, but this much gives how much? 2 into 10 power minus x minus y ml. So that means by burning 10 minus x minus y ml of acetylene, you are getting 2 into 10 power 2 into 10 minus x minus y ml of carbon dioxide. And for this combustion, you need 5 by 2 into 10 power 10 minus x minus y ml of oxygen. Now come to the problem one. So to solve this one, I am coming to the problem. You see, 10 ml of mixture and 30 ml of oxygen. You started with 30 ml of oxygen. Now you focus on the oxygen. 10 ml of this mixture is burned in the presence of 30 ml. Maybe entire 30 ml is consumed. Maybe something is left on the reaction. In this one, papers are to wording. I suspect some oxygen is left after the reaction. How I suspect the words you see? 10 ml mixture, 30 ml oxygen are sparked together and passed through over the aqueous cavity. The volume contracts to 5.5 ml. That means after removing all the carbon dioxide, the remaining contracts to the remaining volume is 5.5 ml. The entire thing is taken, carbon dioxide is removed by KOH, volume is coming to 5.5 ml, contracts to 5.5 ml. That means remaining 5.5 ml. That 5.5 ml disappears when you pass this one over alkaline pyrogallon. That means that 5.5 ml must be oxygen gas. So you started with 30 ml, 5.5 ml oxygen gas is left after the reaction and then disappears when pyrogallol is introduced. Okay, now. So the volume of oxygen remained after the reaction 5.5 ml. Initial volume, I taken 30 ml and volume of O2 consumed during the reaction. So in this reaction, this is the volume of O2 consumed. In this reaction, 3y ml. In this reaction, 2x ml. 2x ml plus 3y ml plus this one. Volume of O2 consumed during the reaction. 2x plus 3y. 2x is for methane, 3y plus ethane. And this is for acetylene. I simplified this one, simple mathematics only. So I simplified this one. This is written directly, this is written directly. 5 by 2 into 10 separated. 5 by 2 into x. 5 by 2 into y. I kept the signs as it is. And this is very easy calculation. This is nothing but 25. I written 5 by 2 as 2.5, here 2.5. So that I can do the easy calculation. 2x minus 2.5 now. So 2.5 subtracted, that means 2.5, 2 is subtracted, 0.5. Because this is having negative, you will get minus 0.5x. 3y minus 2.5 now. So from the 2.5 subtracted, you will get 0.5. And plus is a bigger number is having positive, you will get a plus 0.5y. The remaining 25. Okay, so this is the volume consumed during the reaction, and this is the initial volume taken. This is the volume of oxygen left. That means volume of oxygen. This is the initial volume taken. This is consumed during the reaction. Volume left means 30 minus this one is equal to 5.5. Paper sector given 5.5 ml volume of oxygen left in the reaction in an indirect way. So we have to simplify this equation. I'm just expanding this equation. Negative sign, I multiply the entire thing with the negative sign. Negative, positive is there. So my negative, positive, negative 0.5, negative, negative, positive, and negative, positive, negative 5.5. So I will keep the numbers one side, I will keep the variables one side. 30 taken this side, minus 30, minus 25 taken this side, plus 25. Here this one is left. So I just writing this one here, and this simplification I will get 0.5. And I will divide entire equation with 0.5. If entire equation is divided with 0.5, and you will get, that means I will divide entire equation with 0.5. I can divide like this. The value does not change, and you will get this one cancel x, and this one cancel y, this one cancel 1. X minus y is equal to 1. So I written this is the first equation. I just got one equation. I told you, no, this is not a straightforward problem. It's a big one and good one. Now you see. So I used this information. Whatever the paper sector given, that means this entire information I used already. I don't have any other information to get another equation. I have to get another equation. Two variables are there, x and y. To find the two variables, I need two equations. I got just one equation. To get the another equation in terms of x and y, I have to look for another data given by paper setter, and I am focusing on this 11.3. What is that 11.3? That 11.3 is nothing but vapor density of a mixture. So vapor density of a mixture is 11.3. You can find molar mass of mixture. You already know the equation related to molar mass of mixture. I am going to use that. Okay. Now, after this first equation, I will come to that point now here. So this is given vapor density of mixture is equal to 11.3. So 11.3 means molar mass of mixture is vapor density multiplied by 2. That is molar mass of mixture. So what is the equation related to molar mass of mixture? You can find molar mass of mixture with this equation. What is this one? Mole fraction of methane into its molar mass, mole fraction of ethane into its molar mass, mole fraction of ethane into its molar mass. I'm having molar mass of methane, and this one, very simple, straightforward, I can calculate. But mole fractions, how to do that? Generally, to find the mole fraction of a gas in the mixture, we will take number of moles of that gas by total number of moles. But I'm applying Avogadro's rule now. That means I'm carrying the entire experiment at constant pressure and temperature now. Volume is directly proportional to number of moles now. So whenever number of moles are there, I am using the volumes now. So I can calculate mole fraction, volume of a gas divided by total volume of gas mixture. Total volume of gas mixture, I taken 10 ml of gas mixture, it is 10. And for methane, it is the X I taken. For ethane, I taken Y. For ethane, it is 10 minus X minus Y. That means I am having all the information required to solve this one. So molar mass of mixture, I substitute 22.6. Mole fraction of methane means volume of methane by total volume of gas mixture. This one as it is written. Mole fraction of ethane means volume of ethane by total volume of gas mixture. This one as it is written. Mole fraction of ethane means volume of ethane by total volume of gas mixture. And this is carried over here. And this one, instead of that one X I taken, I assumed that total volume is 10 ml. This one is 16. This one is Y. This is 10. This is 28. This one is 10 minus X minus Y. This is 10. This is 26. Only thing is I have to simplify this one. Simplifying means don't do hard calculations, and you can take 10 common, take the 10 common, and you can also take 2 common. 8, 16, 28, and 26 means you can take 2 common. So you taken 10 common out of this one, remaining thing is x. You also taken 2 common, remaining thing is 8, so 8x, 14 y, and it is 13, 13, 10 minus x minus y. Okay, so 22.6 is nothing but this one. Now you say, I simplifying this one. Now I will simplify, I will expand this one. 13 into 10, that is 130. 13 into minus x minus 13x, 13 into y minus 13y. I simply expanded this one so that I can simplify. So 8x minus 13x is minus 5x. You know how to do that. 14y minus 13y is equal to simple y and 130. This also I simplified 2 1 times 2 5 times. I will take 5 this side. So 5 into 22.6 is equal to minus 5x plus y plus 130. So this I multiplied, I will get 113, and I will take minus 5x this side, 5x, plus y this side, minus y, and 113 I will take this side. 130 is already there, 113 is taken this side, minus plus positive sign, it becomes minus. I simplified this, that is 17, and I got equation number 2. So I'm having two variables. I'm having two variables. When to find the two variables, I need two equations. So I got these two equations. Okay. So from these two equations, what is the first equation? This is the first equation, and this is the second equation. I can simplify x and y. So x minus y is equal to 1 is the first equation. I take this y this side. So x is equal to 1 plus y. This value I substitute here. So 5 into, instead of x, I substituted 1 plus y. Here already minus y is there, 17. I just expanding this one, 5 into 1, 5, and plus 5y, and minus y. So 5y minus y is 4y. 5 is taken this side, 17 minus 5, that is 12. So 4y is equal to 12, means y is equal to 12 by 4, that is equal to 3. You got y here. What is y? That is a volume of ethane, 3 ml. Once you got y, you substitute y here. Immediately you will get x is equal to 1 plus y. So 1 plus 3, that is equal to 4. So volume of methane, I take in x, that is equal to 4 ml. Volume of ethane, y, that is equal to 3 ml. Now you can comfortably calculate volume of ethyl, 10 minus total volume minus x minus y, 10 minus 4 minus 3, that is nothing but 10 minus 7, 10 minus 7, that is the 3 ml. You see, I find in a given 10 ml of original mixture, methane is having 4 ml, ethane is having 3 ml, ethane is having 3 ml. This is the composition of the given mixture. So in eudiometry, you will have these two different models, and you have to practice many more to get the right confidence, Nana. Thank you, Nana. Thank you for listening. And this is the class for today. Thank you.